So in this video, I'm going to talk about how to name alkenes. And to begin with, I've essentially made a list of things you need to do. And so let me explain this list and then we'll do some examples because that's probably the best way to see this and get the hang of it. And so the first step is to find the longest chain and name the root. And so this step is pretty similar to naming alkanes. And the next thing we're going to do is we're going to number the chain from the end that's closest to the double bond. So essentially what we're going to do is we're going to give the double bond priority and give it the lowest number possible. And then you're going to use numbers to designate where the substituents, or in this case the double bonds, are located, and then use a dash to offset that number. After that, you're going to add the suffix of "ene," since we're naming alkenes. And then finally, you have to add the other substituents or functional groups in alphabetical order. And so this might not make complete sense to you, but let's do a couple examples and you'll get the hang of it. And so let's try and name the molecule below. So the first step is we're going to find the longest chain and then name the root. And so I've numbered the longest chain and we found that it's 6 carbons. So the root is going to be hex, since hex represents 6 carbons. And so in this case, we have to number from the end closest to the double bond, and I've started numbering left to right. And this is simply due to the fact that whether we number it from left to right or right to left, you're going to get the same number for the double bond. So the double bond is always going to start on the first carbon, but we also have to give the other functional groups low numbers as well. And so numbering it from left to right would place this methyl group on the second carbon instead of the 5th if you numbered it the other way. And so we know that we have alkenes going from 1 to 2 and 5 to 6. And so you would number that. And we also have a methyl group on the second carbon. And so let's name this. And so this molecule would be named 2-methyl-hexa-1,5-diene. Or the other way you could write it, the older way, I guess, is 2-methyl-1,5-hexadiene. And the only difference is the 1,5 in the first one is closer to the diene. And so you could write it either way. But the point is, you have everything accounted for. And so the 2-methyl represents the methyl group on the second carbon. Hexa represents the number of carbons in the chain, in the longest chain. And the 1,5-diene represents the 2 double bonds and where they start. So it's 1,5 because it starts at the 1 carbon and goes to the 2, and it starts at the 5 carbon. The double bond starts at the 5 carbon and goes to the 6. And so just so you know, I'm just going to name it mostly using the way right over here, so that way, in future videos. And so let's move on to another practice problem. And so here I've drawn another one, and just take a second, pause the video, and do it out. And so here I've numbered the longest chain, but this is a unique molecule in that it really doesn't matter. You could go left to right, so this way, or you could go right to left, or you could go this way, and it would just be the exact same thing. And so let's try and name it. So remember, you have an alkene starting at the 3 carbon, and also on the 3 and 4 carbon, that group is called an isopropyl group. So you have that on the 3 and 4. And then you also have methyl groups on the 2 and 5 carbons. And so just put that all together. And so the name of this molecule is 3,4-diisopropyl 2,5-dimethyl-hex-3-ene. And so something that I like to do is I like to write out all of the functional groups and things that I need to do. I mean, to put in the name. And so that really helps me. And in the next video, I'm going to do some more practice problems just because I don't want to drag this video on. And so I think in general, just for these types of questions, it's just practice and just doing a bunch of naming problems. And so I hope you liked this video and found it useful. If you did, please give it a like and share it with your friends.